Unit 6, Video 5, comparing and contrasting functions between quadratic, exponential, or linear using the graphing calculator. First example, use the functions f of x equals 3x squared and g of x equals 3 to the x power and your graphing calculator to answer the following questions. The questions are, over what region is f of x greater than g of x? Over what region is g of x greater than f of x? What are the solutions to the systems of equations f of x and g of x? And describe the difference in how the two functions grow over time. Which function has a greater value as x approaches infinity? Okay, so we'll start with A. Over what region is f of x greater than g of x? What I need you to do is I need you to go and type in these two equations up here into your graphing calculator. Okay, now that you have done that, I want you to do second table and go directly to the table. You can look at the graph if you want, but we're going to go from the table on this information. So what it is asking me is, in my y column, and this is one thing that I did, I wrote, okay, that's my y1, and this is my y2. I wrote that for my own benefit so that I knew which one was f of x and g of x when looking in my calculator. And what they're asking me is, where are the numbers in the y1 column larger than the numbers in the g or the y2 column? Okay, so when I did this, I saw, all right, so from negative infinity to up until we get to the 1, f of x is definitely larger numbers, okay, because we've got a bunch of decimals in the other one. And then definitely between 2 and 3. I don't know exactly what's going on between 1 and 2. I could look at the graph. So it's probably going to 3. So either way, that would be fine. But I went ahead and separated it because I just, looking at the table, I wasn't 100% sure that it was all doing that. Okay, that's it for A. That's all it's asking. Look at the table. Where are the numbers bigger in the y1 column compared to the y2 column? In B, it's asking the opposite. Okay, so now where is the numbers in the y2 column bigger than the numbers in the y1 column? Well, we can see this at 4 all the way to infinity. That's when that's getting bigger because, again, it's an exponential graph. What are the solutions of the systems of equations? So here you're looking for where do the y1 column and the y2 column match up. I found 2 places. I found 2 nice pretty places anyway. 1 and 3 is where they match up, where you see that 3 in y1 and y2. And I saw at 3 and 27. So where x equals 3, both of the y values are 27. So they have a nice pretty point. And then the last one says, describe the difference in how the two functions grow over time. Which function has a greater value as x approaches infinity? And my answer to that is g of x grows at an exponential rate, while f of x is a quadratic function. Very important to answer in this way. So while g of x begins much slower than f of x, it eventually has a significantly greater rate of change and thus ends up having a greater value over time. All right, what are the appropriate solutions to the following systems of equations? Here they are: y equals x squared minus 3 and y equals 3 minus x squared. And just for the record, of course, you could graph it, but the y equals x squared minus 3 is this one. So this is y equals x squared minus 3. And then this guy right here would be the y is equal to the 3 minus x squared. And they're asking us, these are our answer choices, which one of these is correct? Well, when you're plugging this in, and of course they didn't give you the decimal formation, but you see right here, that's a point. Right here is a point where they cross, and right here is a point where they cross, or the systems, that's their solutions, where they're meeting up. So I know that that's not negative 3 and positive 3 because negative 3 is over here, positive 3 is over here. So I could eliminate that. I know it's not negative 9 and positive 9 because negative 9 is over here and positive 9 is off the little thing. So I know it's not that. Well, I know that the square root of 9 is 3, so I know it can't be those again. So with even just the process of elimination, I can see it's this. If you type this into your calculator, you end up getting 1.73, which is why this is your correct answer. Okay? All right, so this next example says, which of the statements are true about the systems of equations below? You have f of x equals x squared plus 3x plus 2, and g of x equals negative 5x plus negative 4. So first of all, what I would do if I was tackling this problem, I would plug it into my calculator and look at these two graphs. So the first thing says the system consists of two lines. That is false. Anytime you see an x squared, that is not linear. That is quadratic, okay? The second thing says the system consists of a line and a parabola. That is true, because as I said before, we've got this right here is our quadratic that we've been doing a bunch with, and then this is that good old line that you've done from middle school on. The system has only one solution. That is false. Oftentimes, when you have a line going through a parabola, you will meet in two different places, okay? And again, if you graph this on your graphing calculator, you will see this. And then the last one says, the system has two solutions. Well, obviously, if it's false that it has one, in this case, it is true that it has two. All right, the next example says, explain in your own words what changes has occurred on the graphs between the two equations listed below. F of x equals x squared plus 3, and g of x equals 3x squared minus 5. So, let's go with this. So again, I would type this into your graphing calculator as your first resource there so you can visually see what's going on. And then we're going to see the following. Okay, so after I put it in the graphing calculator and I looked and analyzed these two, this is what I came up with. F of x begins at a higher point. So I'm looking at that vertex, which it is at 0, 3. Okay, and I can see that from my graph. G of x begins at a lower point. 0, negative 5. Again, that is my vertex that I'm looking at. So the vertexes are clearly different, so you would state that. And g of x increases at g of x increase at a faster rate than f of x due to the 3 sitting to the left of the x squared. So this right here increases that rate, so it's a steeper parabola in that sense. It's not as wide as the x squared plus 3. All right, this example says use function A and function B given below to answer the following questions. So in A, you have a table. In B, you have a graph, okay? And they ask me to determine the equation for function A. How do you know it's an accurate equation? Determine the equation for function B. How do you know it's an accurate equation? Do the graphs have any zeros in common? If so, what are they? And true or false? If false, state false and explain why not. Function A and function B both have a minimum value. All right, so for room, I bounced over here. So I need to determine the equation for this. Now, in class, we learned, and on my notes, I did it both ways. But in class, we talked through how we need to figure out what the vertex is, and then we need to pick a point. Okay? So the vertex of here, when you're looking at this, again, you're looking for the unique value in your y column to help determine your vertex. Well, cool. The 5s are there together. The 8s are there together. So that is my vertex. Okay, so my vertex is 1, negative 9. Then you're picking any point you want. Again, I chose, because I like zeros, I chose the point 0, negative 8. But again, you have your choice. It does not matter. And now we're going to start plugging it in. So I know that my formula I want to play with is the y equals a x minus h squared plus k. I'm now going to replace what I know. I know that y equals negative 8. I don't know what my a is. I know that, I do know my x. My x is a 0. I know my h is a 1. And I know my k is plus negative 9 or minus 9. So now I'm going to go ahead and solve for a in this process. Now, as you can see what I did, I went ahead and started simplifying. So I had this, so 0 minus 1 was a negative 1, and I just went ahead and simplified plus negative 9 is minus 9. Then I added 9 to both sides, and when I did so, I got a 1 over here equals 8 times 1, so a equals 1. So now I just have to plug it into the formula. And I can leave it in this form. I could go ahead and multiply through this, the x minus 1 times x minus 1, and then add in that other amount, or I can leave it right here because it's in my vertex form and life is good. On to the graph. Now the graph, I can do it the same way where I find the vertex and I find a point, but here's my issue with that. If you look here, my vertex is not pretty, but I have these pretty x-intercepts, which means, and I know I'm going down, so it's going to be a negative, so I can jump to my equation and say I need to have a negative because it's going down, and I know one of my factors is going to be an x minus 1, and I know my other factor is going to be an x minus 4. Okay, so if you see what I did, again, this is why we factor, and we learned how to factor so that we could write equations from this. I know when I was factoring, I was finding this point, the 0, when y equals 0, that's what I was finding when I factored. So that point and that point. So I'm just pulling them and putting them into factored form, and I'm going to multiply it through. And when I multiply it through, I go ahead and do the box method and get to this stage where I'm getting all my factors right now. X squared minus 4x minus 1x plus 4 simplifies to x squared minus 5x plus 4. Remember, there's this negative on the outside, so I need to distribute that through, and I get negative x squared plus 5x minus 4. Part C asks me, do the graphs have any zeros in common? If so, what are they? And the answer is yes, they do. They have 1 at x equals 4. And then the last question is true or false? If false, state false and explain why not. Function A and function B both have a minimum value. False. That is a false statement. B has a max and A has a min. And that is it.